So let's do a quick roll call and then we'll get started. So we have Yug in the class, then we have Avinav, we have Aditi, we have Ananya and Aditya, then we have Asher, we got Tasvik and Nihit as well, then we have Aradhya, we have Praneet, Sriyanvi, Sami, wonderful, everybody. Yeah, the class is looking better now. We have almost everybody. Okay, guys, don't engage into any unnecessary discussions. We have Joy, we have Sriyanvi, and then we have Jaganya as well. Okay, if I missed calling out anybody's name, don't worry, I have my eye on everybody, okay? If somebody is sleeping, somebody is not paying attention, I would get to know. We have Jai also. Alright. So, as I mentioned a few weeks ago, that, okay, and guys, nobody's friends here. It's only student and teacher, no friends. Tasvik? Okay. Come on in. Pick a chair, brother. Yeah, get a chair. So Dada Ananya is also here now. Anika, not Ananya. So, alright. Yeah, Abhinav.
When we start the lesson?
Yeah, just hold it for a little bit. I have to do the jump start first before we start the class, right? So that's what. Just wait for 10 seconds and we will be there. So, yeah. Nikhil, pick a chair for yourself and make sure that you guys are not messing with each other, okay?
Okay.
Nikhil, pick a chair.
Okay.
Alright. So, and guys, no parallel talk. Now, let's look at what are the things that we are going to learn today. I sent a message in the group that was to your parents. Let me just read it for you guys. So, let's look at the topics quickly and then we'll start. So, we are going to talk about decomposing fractions and finding equivalent fractions and then representing fractions on number line. And then we'll also look at decomposing a fraction visually. Okay? So essentially we are going to talk about decomposing a fraction. And then we'll talk about how do we decompose and represent on a number line. And then we'll talk about how do we okay. What was the topic? Last topic I missed. So one more time. Fine. I'll not repeat myself. I'll just look at myself. Okay. Alright. So we'll only focus on how do you decompose a function and how do you find an equivalent of a fraction and then how do you represent that on a number line. Okay. Now I have this as a fraction. Does anybody in the class have a doubt what exactly it is? This is a fraction. One. Yes, Abhinav. You're talking on mute.
I don't really understand what a doubt tree is.
Say that again. What is?
A doubt tree.
Doubt tree.
Oh, I thought you said I would learn about doubt.
No. So we are going to talk about. I'll make you guys sit in 4 different corners of this room. If you guys keep talking to each other, please don't do that. Tasvik and Nihit and Yug and Shiva. These 4 guys are engaged in discussions. I would suggest not to do that because that will disturb the class and you will not be able to learn anything as well. So so the topic that we are going to learn today is understanding what is a fraction, how do you decompose a fraction, and then how do you represent a fraction on a number line. There are 3 things that we are going to focus on. We'll be able to do that only if everybody stays focused and doesn't disturb himself, herself or the class. Okay? Alright. Does everybody know what is this? This is a fraction. 1 is divided by 2. 1 is divided among 2 people. 1 apple is distributed among 2 kids. $1 is distributed among 2 kids. If I say 3 by 8, what it means is I made 3 chapatis and there were 8 kids to eat. So I had to distribute those 3 chapatis among 8 kids. You guys are getting me literally upset. Okay, so I have 3 chapatis and I am trying to distribute it among 8 kids. I know it is not enough, it is less. Everyone knows chapati, right?
Yes.
Yeah. So,
Yes.
it is not enough, but this is the situation I'm dealing with. So, this, okay. You have enough?
I know the answer.
I don't need the answer. Allow me to complete the concept part of it. When time comes, I will let you guys solve the problems also, okay? Because let's focus on the concept first.
Okay.
Okay, Nihit, you come here. You'll sit next to me. Just 1 second, kids. Nihit, you'll sit here. Come here, quick. I cannot wait half an hour just sitting, helping you settle down. And Shiva, you'll move 2 feet away from you. Okay. So this is what is fraction. When you're distributing something among certain people. If I say 4 by 8, probably I'm talking about a situation where I have 4 oranges and there are 8 kids. Or I have 8 friends and I have only 4 oranges. So I distribute the oranges among my friends this way. 4 divided among 8. This is nothing but a fraction. Okay. So whenever you see a fraction like 12 by 8, it means you have probably $12 or 12 apples, 12 oranges, and you are distributing among this many people. Whatever is the denominator, that is the number of people who are looking for this. So that is how they distribute it. Okay. If I say, let's say in this class we have around 15 kids right now, and I have only $2. If I have to distribute $2 among all of you, this is how I will divide. I divided $2 among 15 kids. Whatever it comes to, I know that will be of no use. Still, this is how you divide. Yeah, Vinay, tell me, you're saying something. Are you singing a song? No? Okay. Alright. So, this is what is meant by fraction. Now, interesting thing here. A question to everybody, okay? If I have 1 by 2, 2 by 4, 4 by 8, 3 by 6, 7 by 14, 8 by 16. Is there any relationship among these? Do you see something very unique or interesting about them? What is that?
That the top part is all. They're both halves.
Okay. They are all halves. So, if you look at it this way, 2 divided by 4, everybody gets half. 4 or you can say they are all halves, or you can say that your numerator is half of the denominator. Here my numerator is half of 2. My numerator is half of 4. My numerator is half of 8. Yeah, Pranit.
Also, the first 2 are 1, 2, then 2 comes on to 4, 2, 4. 4 comes on 4 and 8, 4, 8, 8 comes on 8 and 4, 8, 4.
Right, so that sequence has no meaning here as such. The only thing that you might want to observe is, here my numerator is half of my denominator. Look at 14. 14 is, sorry, look at 7. 7 is half of 14. Look at 8. 8 is half of 16. Look at 4. 4 is half of 8. 3 is half of 6 as well. I can also write 15 by 30 and still I see the same behavior where this is half of this guy. Yeah? Yeah? So, Anika, Aditya, are you guys with me? Ankita. Ankita and Anika are two different kids, two different names. I should not be messing up with the names. Sorry about that. So yeah, everything that you see here, one unique property that you observed is your numerator is half of the denominator. And hence, somebody said they are all halves. Okay? Meaning, everybody's value is the same, no matter how big they look. Even if I put 100 by 200, interestingly, this and this are same, this and this are same, this and this are same. Okay? Everything is half.
Yeah.
So this is called equivalent fraction.
Yeah.
Okay? So now look at this. You can literally play with this. If somebody says, I am giving you 3 by 8. Find out another equivalent fraction of this. Meaning, something which doesn't look the same but has the same value. That is what is equivalent fraction. When I look at 1 by 2 and 2 by 4, you guys said they are all half, meaning same value. If I say $1 divided among 2 kids, everybody gets 50 cents. $2 divided among 4 kids, everybody is getting 50 cents still. Yeah?
Yes.
So that's why they are same. They are also called equivalent fraction, meaning their value is equivalent to each other. The final value, okay? Though they look different. So if I have 3 by 8, if somebody says find out an equivalent fraction, what will that be? Now you look at this 1 by 2 and 2 by 4. What happens? If I multiply by 2 and multiply this also by 2, what do I get? 1 into 2, 2, 2 into 2, 4. See, this is what I got. Now if I have 1 by 2 and I am saying 3 by 6 is also equivalent fraction. What I will do is I will multiply by 3 here, multiply by 3. Now what do I get? 3 by 6. So you can get equivalent fraction by multiplying something by the same number in the numerator or denominator. Difficult? Difficult? Interesting? Sleepy? Okay. Now, this is where a game comes into play. We all play games, right?
Yes.
Not the mobile games. Not the mobile games. Those are very bad.
Like tic-tac-toe.
The tic-tac-toe.
Chess.
Okay. We'll come to those games later on. So, now if I have 2 by 4, you know what? I can play with this. What I can do is, I can write 2 as 2 into 1. Is that okay? 2 I can write as 2 into 1. No problem.
Yes.
And 4 I can write as 2 into 2. Is that okay?
Yes. Yeah.
Now, this is when I start playing. I call it tic-tac-toe. So 1, 2 here and 1, 2 here. I can knock them off. This is me. This is my competitor. He said, okay, I will cut your 2. I said, okay, I will cut your 2 as well. Now, this 2 by 4, you did tic-tac-toe, only, see, you can cut 1, 2 and 1, 2 only. You cannot say, okay, this 2 and this 2. No, that will not be correct. 1 from the numerator, 1 from the denominator. That only you can do. And you got 1 by 2. So 2 and 2 gone, it became 1 by 2. Now see, you were saying 1 by 2 and 2 by 4 are same. All are half. And we saw it happening just now. Yeah? If I say 1 by 2 and 8 by 16 also same. Right? That's what I said. You all said that this is half. I'm trying to prove it now. See, 8 by 16. Can I say 8 as 2 into 4? Yeah?
Yeah.
And 16 I can say 4 into 4?
Yes.
Yeah? I will again play. Tic-tac-toe. 1, 4 here, 1, 4 here, gone. What do I have? 2 by 4. I'm still not happy. I want to play more. So 2 I can write as 2 into 1. That's okay. And this 4 I can write as 2 into 2.
Yes.
One more time, tic-tac-toe. What do I have now? 1 by 2. See, 8 by 16 became 1 by 2. That is why they are called equivalent fraction, okay? Because their values are same, and you can always find that out by playing with it.
Equivalent fractions mean that they need to have the same shape and the same size.
Say that again.
I'm talking about the shapes in fractions.
Let's not confuse two things. Let's not even worry about shape right now. Shape is part of geometry and equivalent fraction is part of algebra. So we will not learn algebra and geometry together. We'll keep them separate, okay? Now coming back to this one again. So what did you see? We saw that when my numerator and denominators, happy? Why do I have to keep on telling you guys same thing again and again? I don't enjoy scolding you guys for sure. I mean, do I look a person who
That's cute. That's cute.
do I look a person who enjoys scolding anybody?
No.
So don't force me to change my personality. Okay? Alright. Now, I'm saying all these numbers 1 by 2, 2 by 4, 3 by 6, 4 by 8, whatever. You can just go on 200 by 400, 1 million by 2 million. Okay? These are all equivalent fractions where your numerator is half of the denominator. Okay? So I'm saying that not only this scenario, you can also say that if I have a fraction like this, 4 by 19, and let me not put a complex number here, 4 by let's say 6, and 8 by 12. These are also equivalent fractions. Why? Because I can multiply and divide, so I can multiply the numerator and denominator by a certain number to get this one. Shalini, are you with me? Okay.
Yes.
Okay. So no, just pay attention, everybody. Okay, that's a request to everybody. So I'm saying that how do you define? See, only not 1 by 2 and 2 by 4 are equivalent fractions. Okay, there are many more. Every fraction can have an equivalent fraction. Every fraction that you can think of. Happy? Okay. Okay. From today, I'll do one thing. I will put a counter in the corner, okay? If I see somebody disturbing the class, I'll keep on increasing that by 1 count, okay? So my counting also improves because you guys give me enough chance. Hands down, you are not given a chance to talk because you are talking unnecessarily when you're not needed to talk. Okay, so this is just a reminder for you guys. When you see something number in the corner, if it becomes 50, that means how much disturbance you guys have created in the class. And be happy that I'm not still complaining parents that okay, your child doing this. Okay, so take this as a reminder and don't let me increase the counter. Okay, coming back to this one. So I'm saying every fraction that you have, there can be equivalent fraction. If I have, let's say, 5 by 6, can I find out equivalent fraction for this one? Anybody who doesn't know how to find it out? Yep, yes, Ami?
You can find out the equivalent fraction by multiplying the numbers.
Yeah.
So like let's say 5 and 6, right? 5, 6. You multiply 5 times 2 or whatever number, and since you do it to the numerator, you do it to the denominator.
Right.
Like if you multiply them by 2, you get 10 over 12.
Right. Ashar, tell me. You were saying something.
I actually don't know how to find the equivalent fraction.
So it's very simple, okay? You run, see, it's like doing a magic trick. You have an equation, you want to do some magic. I'm telling you that you can find out as many number of equivalent fraction, okay? Like what Sammy said, I will multiply this and this, both of them by the same number. That is my equivalent fraction. So if you multiply this, what it became? 5 into 10, 10, 6 into 2, 12. This is my equivalent fraction for 5 by 6. If you don't like the number 2, you like 7, wonderful. 5 by 6, you multiply by 7 and here you also multiply by 7. multiplying by the same number is okay. Okay? It doesn't do any damage. Because if you don't like it, you can always do tic-tac-toe. So you're not changing the value. Okay? Okay? Everybody here, Ashar, did you follow me?
Yes.
Yes, Suhina, you have a question.
So, if you need to check your answer, you could do like a butterfly method that my teacher taught me and Shalini.
Uh-huh.
So, we could take the number that we multiplied with, 5 over 6.
Uh-huh.
Then we could multiply 5 and 12. That's going to give us 60. 6 times 10 is also going to give us 60. That's how we know it's an equal.
Right. Yeah. So that is an interesting thing, right? So see, in the old days, it was always like teacher will teach and the students will learn. Now see here, what is interesting happening in the class? Kids are also teaching the teacher, and I'm loving it. Because see, you're not teaching me. I cannot fail now. As many times I had to fail, I have already failed in the past. Now I don't give any exam, so I don't have the option to fail. Okay. So, but it helps you guys, right? On a serious note, let's say when Suhina is saying that you can do a butterfly method to see if this is correct or not. See, this is what is happening. I said that if you have a number, you can multiply by anything, okay? So let's say I picked 4, I like 4. I multiplied numerator and denominator both by 4, it became 20 by 6 times 4, 24. Yeah? So my fraction was 5 by 6 and I found another equivalent fraction is 20 by 24. Okay? What Suhina is saying is, you can do butterfly method, meaning multiply this by this and multiply this by this. If you get the same value, you're good. Right, Suhina? Yeah? So these are different ways to... Tasvik, what did you come to the class for today? To learn something. That's what I'm doing right now. Pay attention here, okay? So, now the summary of what we have seen so far. 2 things. One is, if you have any fraction, you can find as many equivalent fractions for that. Okay? If you have, let's say, somebody is just playing with you and say, okay, find out the equivalent fraction of 2 by 9. Okay? Very easy. You'll say, okay, I can multiply 2 by 9 by 3 and 3, or I can multiply 2 by 9 by 4 and 4. I can multiply 2 by 9 by 7 and 7. I can multiply 2 and 9 by 200 and 200. All are valid. Okay? You can do that. Now, Suhina is saying one more interesting thing, which is called butterfly method. Right? Now, since the winter is almost over, you guys will start seeing more butterflies, right? In spring. You are seeing a butterfly in the math class also right now. Right? So let's say I said 2 by 9, I multiplied by 2. Okay? So that way my life is a little easier. So what is my equivalent fraction here? 2 into 2 is 4, 9 to 2 is 18. So I got equivalent fraction for 2 by 9 is 4 by 18. What Suhina is saying is, now just to check whether you got the right value or not, butterfly. What will you do? Multiply 9 by 4 and multiply 2 by 18 and see if the value are matching. 9 times 4 is what? 36. 18 times 2 is what? 36. Both are same. You're good. Your butterfly told you that be happy about it. You got the right equivalent fraction. So 4 by 18 is equivalent fraction for 2 by 9. That's more like a check that you can do and say yes, this is right.
Okay.
Yeah, sure. No, I mean, if you have a question, you can ask. But anybody in the class, are you guys clear with what we have discussed so far?
Yes. Yes, sir.
Okay. Nikhil, Anika.
Stop playing with emojis, Shalini.
Yeah, please. No playing with emojis. Yeah.
Yeah, no emojis.
No emojis, please. Okay. Mandeep. Okay. Now let the teacher teach. If every student start teaching, there'll be a mess. Now let me quickly check. Praneet, Joy, Jaganya, Shreyanvi, are you guys with me so far? Have you been able to follow me what I've been? Yeah? No, and I call out the names because these were the kids who had not spoken for last few minutes, so that's why I was just checking. Yeah, Abhinav.
Can I tell a number?
Sure.
How about 36 and 25?
36 by 25. 36 by 25. So Abhinav is saying, what will be the equivalent fraction for this one? Correct, Abhinav? Now I will not answer that. Let Suhina answer that. Yes, Suhina.
Okay, so 36 is 6 times 6 can make 36, but 36 times 6 and
Okay, see, you guys probably are overthinking, okay? As I said, you can pick up any number, any fraction, and you can decide a number, okay? I don't like big numbers, I like small numbers. I'll multiply this by 2 and multiply this by 2, done. If I like bigger numbers, maybe I'll multiply this by 4 and multiply this also by 4. So 36 times 4 gives me 144 and 25 times 4 gives me 100. So you can choose. You can always choose, okay? If you are in an exam-like situation where you have multiple questions to solve, don't attempt to use a big number because your calculation will become bigger and you'll take more time and you'll have less time for other problems, okay? So always choose the smaller ones. Keep your problem as simple as you can, okay?
Sir,
Yep.
this is like out of the class thing, but yesterday we learned of border mass, right?
Mm-hmm.
So I got an easier way to remember border mass.
Okay.
So brackets of donkey, monkey, alligator and snake. So brackets is like a cage, and the donkey, monkey, and those guys are in like that cage.
Okay. Yeah. So again, so this is what I would want you guys to do. But yeah, we'll try optimally using it. This week we are very busy today. Very busy, doing things which is outside the syllabus. Don't do that. Now, coming back to the next part, which is called decomposing a fraction. I have a fraction 1 by 2. Okay, I want to decompose this. What is the problem? No, this problem has to be fixed. This problem you cannot survive it for long because this is still a very, very young age, and things will get more complicated if you don't pay attention. Okay. Mandeep, can you take the pig out of the class? Yeah, Mandeep, go ahead. No, so don't do that because this takes everybody's attention there, okay, and that's not good. Now, what we are talking about is decomposing a fraction. Meaning, if I have a fraction like this, can I break this into two fractions? Yaditi.
Yeah, because you can draw a lot. If you're making a fraction and you shade one part, you
can break it.
Then you can't.
You can't break it? You can't break it? Yaditya, Ananya.
You can break it up you can break it up into thousands.
Okay, I have an easier solution always, okay? I'm not as intelligent as you guys are, okay? So I always look for simpler, easier problems, easier solution. See, I told you, if I have 1 by 2, okay? I can multiply and divide by same number. Is that okay? That is okay, right? That's what we learned. I had 1 by 2, it became what? 2 by 4. Yeah? Can I say 2 by 4 is nothing but 1 by 4 plus 1 by 4? If I say 1 by 4 as a banana, 2 times 1 by 4 is 2 banana, right? So here I have 2 bananas. One banana here, one banana here. Yeah? Look at this. I had 1 by 2. What did I do? I said, whenever I have a fraction, I can multiply and divide by the same number. Or multiply numerator and denominator by the same number. So 1 by 2 became 2 by 4. Okay? 2 times 1 by 4. 2 times 1 by 4. 1 by 4 is a banana. I'm saying 2 times 1 by 4. 2 bananas. So 1 banana here, 1 banana here. I decomposed 1 by 2 into 1 by 4 plus 1 by 4. And I'm not happy yet. I want to do more. Because I love playing with math. I want you guys to play with math. I'm saying, okay, I want to decompose this. How about this? I have 1 by 2. Let's pick up another number. Okay? Let's say I have 2 by 6. Okay? 2 by 6 if I have to decompose. If I think about it, it's like 2 times 1 by 6, isn't it? Look at this as apple. 2 times apple. 2 apple, isn't it? So I will say 1 apple here plus 1 apple here. This will give me 2 apples. Yeah? If I have 1 by 2 alone, again, let's say not 1 by 2, let's say 1 by 7. Okay? I want to decompose this, meaning I want to create more fraction. See, what did we do? 2 by 6, I split that into 2 fractions. So I decomposed this, I broke this into 2 parts. Right? Let's say, if I can break this further, 1 by 7. How about multiplying and dividing by this? It's same thing, right? Equivalent fraction, value is not changing so far. So it became 3 by 21. If I think of 1 by 21, or I can write this as 3 into 1 by 21, no problem. Yeah? This is 1 monkey. 1 by 21 is 1 monkey. I have 3 monkeys here. Yeah? So I will say 1 monkey plus another monkey plus third monkey. See, 1 by 7, which was my original fraction, I decomposed that into 3 fractions now. Yep? Yeah, sure. Sure. Yep. Suhina has a question. She did not like the monkeys.
No, how about if there's like a big number, are we gonna write those many ones in?
So you have to always look at it this way, okay? Let's say this. You have to always use your tables little bit, tables knowledge little bit. Okay, let's say you have 15 divided by 24. Okay. Mandeep, whom are you talking to? Keep yourself on mute. And try not to do anything apart from math for next, how many more minutes? Next 24 more minutes, okay? I'll make sure that I talk not like a grandpa and give you a lot of loaded information. I'll keep it like the way you guys will understand, okay? I'll keep it simple. Now, this is my fraction, yeah? I want to decompose this, okay? If I have this, how about this? 15 into 1 by 24, I can say this? Yeah? If I think of this as one hippopotamus, yeah? I have 15 hippopotamus here. Yeah? I'll say 7 hippopotamus plus 8 hippopotamus. Or it becomes 7 by 24 plus 8 by 24. Is this okay?
Yes.
Yeah? Aditi, are you with me, beta?
Yes, sir.
Ananya, Aditya, everybody with me? You're liking hippopotamus? Okay. Alright. So,
Yes, sir.
what is that? Okay.
Sir.
Now let's look at another wild animal. If I have, let's say, 15 by, huh? 15 by 18? Okay. 15 by 8. Now, I can always think of this. Always look at how you can make a easier, build an easier picture. Neat and Tafik, you guys can be friends outside this classroom. I have told you at least 50 times. This 3 became 3 plus 3, 6. I have already stopped you guys at least 6 to 7 times from doing things which are not needed in the class. This number becomes 1 million. What it would mean? That we are not studying in the class at all. We are only messing around. Let's make sure that this doesn't go to this number, okay? And I would need everybody's support and understanding here. Otherwise, you guys will come to the class and not learn anything. And your parents will be really upset about it. Okay?
Yes.
Alright, so coming back to this, 15 by 8, that's the question I got from Shiva. He's saying, okay, can I decompose this fraction? Yeah, everything is related. 15 by 8, can I look at this as 15 into 1 by 8? 15 I can write as 15 into 1, right? No problem. Now, this is a giraffe. I have 15 giraffe. 15 times 1 by 8 I am saying as giraffe. I gave it a name. I have 15 giraffe. So, 15 giraffe I can make two groups of them. They will play American soccer tomorrow together, right? American football. So I have 15 giraffes. I want to make 2 teams of giraffes to play American football. So I will put 8 giraffes in one team, or maybe 9 giraffes in one team, and then remaining 6 giraffes in another team. Yeah. So see, 15 by 8 became 9 by 8 plus 6 by 8. If you want to make 4 teams, you will say, okay, fine, probably 4 giraffes in one team, then another 3 giraffes in another team, then another team has 6 giraffes, 4 plus 6 plus 3, and then 2 giraffes in another team. So you could break this 15 by 8 into 4 fractions actually. Yeah. Is this team looking good?
Yes.
Yeah.
Yes.
And nobody will win. This team is very strong. But the fact of the matter here is that when you have a fraction, you can look at how you want to break it into smaller pieces. Now, there's one thing to notice here. One thing to notice here. With this one, what did I do? Just notice, just pay attention, okay? This will give you guys one clue here, good clue here. If I had this, what did I do? I said 15, I can write as 15 to 1 by 8. So this one I'm counting as a giraffe. So I'm saying, okay, 15 giraffe, which is equal to maybe 8 giraffe and 7 giraffe. That is what makes 15 giraffe. 8 giraffe, 7 giraffe. Yeah. Or this became 8 by 8 plus 7 by 8. Now, look at it carefully. You have this value. Your denominator is the same in both the cases. This 15 got split into 8 plus 7. And this is, okay, so let me first tell you guys one quick thing. There are 2 types of fraction. One is called proper fraction and one is called improper fraction. Like we have 2 kinds of students. One is proper student, one is improper student. Proper students are the one who pay attention in the class. Improper students are the one who help me increase the counter here. Okay?
Who's an improper student?
Who is asking the question? Based on your performance today? Yeah, and there are more who are keeping quiet right now. But anyways, so my message to you guys is pay attention now. Let's not look at the joke of it. Let's look at the serious part of it. Here, when I have 3 by 8 and 12 by 8, what is the difference between these two? Yeah, Aditya. You had raised your hand.
No, I was gonna say about the improper and proper fraction.
Okay, fine. So let's see what Joy had a question for. Yeah, Joy. Yeah, raise your hand.
12 is 4 more than 8.
Yes. So basically, look at this situation. I think Aditya knows about it. I'm just repeating it for everybody's benefit. When you have a fraction, when your denominator is bigger than this one, and here your denominator is smaller than the numerator. When your denominator is smaller than the numerator, it's called proper fraction. And when your denominator is smaller than your numerator, it's called improper fraction. What is proper? What is improper?
Sir,
Yep.
proper is a fraction within the denominator. So like 3 and 8.
Uh-huh.
8. But improper fraction is outside of the denominator, like a mixed number.
Right.
But without like.
So I will. So I will not put too many things together. Just for everybody to follow, I will say when my numerator is bigger than my denominator, that is improper. Yeah. When my so look at this one. Now if you look at this, my numerator is bigger than this guy. Correct? So this is an improper fraction. When I'm looking at 3 and 8, my numerator is smaller than my denominator. This is a proper fraction. Yeah. So now, taking that information here, if you are dealing with an improper fraction like this, 15 by 8, let me give you guys another situation. 4 by 3, is it improper or proper?
Proper.
4 by 3 is proper? Improper. Because your numerator is bigger than this denominator, okay? So this is improper fraction. Now, when you have a situation like this, when you're dealing with improper fraction, your job is much easier. You don't have to do much calculation actually. Look at this. 4 by 3 was nothing but 4 into 1 by 3. Yeah? You can always say 4 apples, let's say. So, 3 apple and 1 apple. Or you can say 2 apple and 2 apple. This is apple. This is apple. Yeah? Yeah, sure.
I got him.
Yeah. So I'm saying when you're dealing with improper fraction, you don't have to multiply because it's much easier actually. Or if you don't want to get confused, even let's forget about this concept itself. Let's not worry about proper improper fraction. We'll learn and apply only one method, that if I have a fraction, if I have any fraction, 1 by 8 or 15 by 8, whatever it be, I have only one method to follow. If I have to decompose this versus decompose this, okay, here let me multiply this by 2 and multiply here also by 2. Here also I'll multiply by 2, multiply by 2. That's fine, that's okay, no problem, no damage done. This becomes 2 by 16 and this becomes 30 by 16. When you're dealing with this, okay, 2 into 1 by 16 and this is 30 into 1 by 16. So this is raccoon and this one is elephant. Then this becomes 1 raccoon plus 1 more raccoon. Here this is 30 elephant. So 15 or let's say 14 elephant plus 16 elephant. Done. Yeah? Yes. Who has raised the question? Yeah, Aditya, Ananya. Sure. Okay. So, when it comes to decomposing a fraction, this is how you will do. And pick up a smaller number, okay? Don't overwhelm yourself by picking a big number and then you have to deal with a large, very big calculation. Yeah? Is everybody clear?
Yes. Yes.
Okay.
Yes, sir.
Okay.
Yes, sir.
Now comes representing the fraction on a number line. Who knows how to do so? Yeah, Diti.
I know how to do so.
Okay. Yeah, Mandeep.
I also know it.
Wonderful. Salmi.
Can I explain it?
No. I'll just teach it for everybody's benefit in the easiest form. Yeah. You also know it? Yeah. Okay, cool. So I will see. This is my number line. Okay, I'm just explaining that in the easiest form so that whoever knows it can review. Whoever doesn't know it can learn quickly. Everybody knows number line, right?
Sir, Star Trek, will you teach coordinate plane?
Yeah.
Okay.
Coordinate plane, I think I taught in one of the previous classes, but I'll pick it up in the next class as well. Okay?
Yeah, you didn't go very in depth, but
For your grades, I don't think there'll be a lot of deep concepts needed, but yeah, we'll look at all the conceptual aspects, and if there's something missing, we'll cover that. Yeah?
because I'm in 5th grade and they said it would be in the start.
Sure. So, trust me, even the coordinate plane that we learn in the 9th or 10th grade also, that also you'll be able to relate when I teach it, okay? So don't worry about it. Yeah, Jay. Yeah, I'll come to you. Bathroom? Go ahead. Yeah. Sure. Alright. So this is a number line. Everybody has seen this enough, right? I'm assuming that there is nobody having any problem, right? So in the number line, this is 0, 1, 2, 3, 4, 5. This side -1, -2, -3, -4, and it just goes on depending on how big your board is. Now, if you have to represent 3 on a number line, very easy. You know this is 3. Yeah. But you'll have to wait for Tasvik to come out. Okay. If I have to represent -2 on this number line, it's very easy. Here. If I have to represent 0 on the number line, we all know where it is. If I have to represent 1/2 on a number line, so 1/2, again, start thinking. See, again, this number line would be your base for coordinate plane also. So make sure that while I'm teaching number line, relate or think that this is your preparation for coordinate plane also. Okay? Now, when I'm saying 1/2, 1/2, what? Yeah. Saying something, Sammy?
Sorry, sir, just clicked.
No worries. If I'm looking at 1/2, now you have to first think, what exactly does it mean? It's 1 divided by 2. This is a proper fraction, meaning where my numerator is less than denominator. Its numerator is less than denominator, meaning there is only one apple divided among 2 kids. So nobody is getting one complete apple, right? Okay? Or if it's $1, it's divided among 2 kids. So nobody is getting $1 or more. It's less than $1. So it's more than 0. It's better than not getting anything, but it is less than 1. So it's between 0 and 1. Yeah? It's not 0, you are getting something, but not getting one complete dollar, because that $1 got divided among 2 kids. So you are getting more than 0 but less than 1. So it's somewhere between 1 and 2, 0 and 1. Now this is 1/2. So whatever is for 1 is divided among 2. So between 0 and 1, here to here, whatever was the value that got divided among 2, and we are looking at the middle point. If somebody says represent 1/3 on the number line, then you have to look at, okay, this is more than 0, less than 1. And it is 1/3 of 1. 1/3 of 1. Yep. Sure. Sure. But you have to wait for Shiva to come. Otherwise you guys will be queuing up in the bathroom, which is not a good sign.
His name is Satvik.
It's okay. That is outside the syllabus for maths. I only know him as Shiva. Okay, that's fine. Now, 1/3, you read this way. 1 divided among 3. So, 1/3 of 1. So, 0 to 1, this is 1. If you break this into 3 parts, 3 equal parts, this is 1/3. This is 2/3. And 3/3. 3/3. See, this becomes 1. So, always look at, if you have to represent 1/4, same thing, 0 to 1, you will break it into 4 parts and this will be 1/4. This will be 2/4. This will be 3/4. And this will be, the one place will be 4/4, which is nothing but 4/4 is how much?
1.
4 into 1 by 4 into 1. It becomes 1. Yeah? So, you have to first you have to visualize where exactly it will be, and then you are looking at how many pieces of that part you are going to make. Let's say, let me make this number line a little bigger. I'm zooming in. Okay, this is not a camera where I can zoom in, but let's say my number line has 0 here and -1 here and 1 here. Okay, I zoomed in. Now, if you have to plot 1/4. What does it mean? I have to break this into 4 parts. 1, 2, 3 and 4. I have 4 parts now. 1/4. 1/4. If you look at this one, this will be 2/4. This will be 3/4. And here 1, which is nothing but 4/4, which is 1. So you have to always visualize it that way. If somebody says find out 1/8, that means you will break this into 8 parts. This is 1/8, this is 2/8, this is 3/8, this is 4/8, and here it becomes 8/8, which will be 1. So, you have to visualize how you are going to break a number into how many parts. That's exactly what is happening here, right? 1 got divided into 8, and one portion of that is called 1/8. Does it make sense, or it's getting you guys confused?
I think it makes sense, sir.
Okay. Anybody else in the class who's not happy with what we have learned so far?
It makes sense to me.
Okay. Okay.
It makes sense to me. Not to me.
Not to you?
No. No.
Did not make sense to somebody? Pranit, was that you?
No.
I'm sorry?
Not here. That doesn't understand. Sort of.
Now you guys are giving me little cryptic answer. Is there anybody in the class who did not understand what I said? And it's okay to say I did not understand, that's fine. So Abhinav understood. Abhinav understood, okay. Pranit, are you clear, beta?
Kind of.
Kind of. So that kind of gives me a reason to waste your, everybody's 1 more minute, okay? And then I'll let you go. Yeah? You don't get it? Okay, so that's what we'll do. Now, this was the last part that I wanted to cover, and that will make it very easy now. Let's say this is 0 and this is 1. I have zoomed in on the number line. This is 0, this is 1. Okay? Yeah?
Yeah.
Imagine this one as a bar, a candy bar. Interesting, right? A good candy bar. Yeah? This is a long one, and I'm sure everybody here. Let them come, that's fine. Now, if I say find out 1/4, what you're going to do? You're going to break this bar into 4 pieces. Right?
Yes. Yeah.
Well, this is stripped iron.
Whatever it is called, that's okay. Let's look at this as a candy bar. And Advik and Arab, you guys have to wait. Let this class get over. Outside the class. So just wait for 2 more minutes, okay? Let's be a little disciplined. Now, I have a candy bar and I'm saying 1/4, meaning this candy bar is going to be divided among 4 kids. And this is what we did. We divided this into 4 pieces. Everybody gets 1 piece, correct? Yeah?
Yes, correct.
This is 1/4. This is also 1/4. This is also 1/4. This is also 1/4. Yeah?
Yeah.
So if you think of this as a number line, this is your 1/4. This is where your 1 piece is going out. Yeah? Now, if I take 2 kids together, that is 1/4 plus 1/4. That becomes 2/4. So this is your 2/4. Now if I include third kid also, then this is 1/4 plus 1/4, 2/4 plus 1/4, 3/4. Yeah?
Yeah. And then next it's 4/4.
This is 4/4. This is nothing but 1. Yeah?
Why does it say 2/4, 2/4, 3/4, and 4/4?
That is what I have been telling for the last 1 hour. Advik, Arab, nobody will intercept in between. You have to watch the video of the class because you did not pay attention even for 10 minutes in the class today. I'm very unhappy about it. Okay? So, you'll watch the video, that is how it will become clear. You cannot be busy for 55 minutes and last minute you will think that there is some magic that will happen and you learn everything. No. I'm teaching for the entire 1 hour. You have to pay attention for 1 hour. That is how you'll be able to understand. Okay? So what I will do, you'll be able to relate. Now coming back to this point, this was my bar. I had to divide it among 4 kids. 1 piece, second piece, third piece, fourth piece. Every piece is 1/4. That is how it is divided. This is 1/4, 2/4, 3/4, 4/4. That is how this whole bar is divided among 4 kids. And if you visualize this on a number line, 0 to 1. 0 to 1 was representing 1 bar. Now you are able to represent 1/4, 2/4, 3/4 and 4/4. Yeah?
No, that's what I was saying too.
Okay.
I understand now.
Yeah? Alright.
That's what I was
So,
saying.
yeah.
Doesn't that equal a whole? Yeah, it does.
You have to wake up.
I understand what you're saying.
No, not you, Praneeth. There was one child who was sleeping for long enough, so I had to just wake him up. Alright, so I'll let you guys go. I hope whatever we learned, that you guys were able to understand. Whatever you missed, for that you'll have to watch the video and make sure that you cover the entire thing, whatever we learned. And then Sammy, remind me in the next class to teach you guys coordinate planes, okay?
Bye, sir.
Alright, bye-bye, 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 bye-bye.
Bye.
Bye.
Bye.